Hello students, good morning and welcome to the lecture session. Today we are going to discuss about the solution by Lagrange's method. So working rule for the Lagrange method is, first step is that we will be given a PDE in the form P into P plus Q into Q is equals to R, and we form the equation of the form dx by P is equal to dy by Q equals to dz by R, where the small p refers to this small p, which refers to dou z by dou x, and capital P will be the function of x and y, x, y, z. Q also will be the function of x, y, z, and the small q refers to dou z by dou y, and capital R is also a function of x, y, and z. So when we write it in this form, it is known as the auxiliary equation. In the next step, what we do is we can consider a suitable pairs which can be put in the forms like f of x into dx is equal to g of y into dy, and g of y into dy is equal to h of z into dz. F of x into dx is equal to h of z into dz. So by integration we can get the relation in x comma y comma z, and z comma x as the case may be. We can choose any two pairs like that. We have a property in the ratio and proportion that a1 by b1 is equal to a2 by b2 is equal to a3 by b3 is also equal to k1 a1 plus k2 a2 plus k3 a3 by k1 b1 plus k2 b2 plus k3 b3. With reference to the auxiliary equation, we try to find the multipliers k1 k2 k3, k1 dash k2 dash and k3 dash, so that we can write dx by p is equal to dy by q is equal to dz by r is k1 dx plus k2 dy plus k3 dz divided by k1 p plus k2 q plus k3 r. Okay. Next step, integrating, and this can be also written as k1 dash into dx plus k2 dash dy plus k3 dash dz is divided by k1 dash p plus etc. Integrating the two expressions, we obtain the two relation connecting the x, y and z. The last step is, suppose u of x, y, z is equal to c1 and v of x, y, z is equal to c2 are the two relations we obtain. Then phi of u comma v equals to 0. It constitutes a general solution of the PDE, that is PP plus QQ is equal to R. So first of all, we have to make sure that the given equation is in the form of PP plus QQ plus QQ is equals to R. If it is in this form, then later on we can follow the steps what I have discussed earlier. Problems. X into dou z by dou x plus y dou z by dou y is equals to z. And here you can refer this, thus as I told you, dou z by dou x can be written as small p, and dou z by dou y can be written as small q, which is equals to r. And the auxiliary equations will be given by dx by x, which p is nothing but x here, and q is nothing but y here, and r is z. So we can write dx by x, that is equal to dy by y equals to dz by z. We can take any two pair of equations, that is we are taking the first one and the second one. Dx by x is equal to dy by y. It is no need to separate the variables, already the variables are separated. Dx is with x terms and dy is with y terms, which can be integrated now. Which on integration we will get log x is equal to log y plus log c, which by taking it to the left hand side we get log of x by y is log of c1, or taking the anti-logarithm x by y is equal to c1. Now let us consider the second and the third term, that is dy by y is equal to dz by z, and we get it as y by z is equals to c2. Thus the general solution of the PDA is given by, previously we got x by y and now we got y by z. So the combination, that is x by y into comma y by z, is equals to 0. This is the solution of the equation. Let's take the next example. Y minus z into p, which is capital B here. This is capital Q. Z minus x into q is a capital Q here. And x minus y is r. So the given equation is of the form pp plus qq is equal to r. And the auxiliary equations are dx by y minus z is equal to dy by z minus x is equal to dz by x minus y. Now, we need to use the multipliers in each ratio. Now, the each ratio is equal to dx plus dy plus dz is divided by y minus z plus z minus x plus x minus y. That means we are adding all the three by multiplying 1 to both numerator and denominators. We will be getting the denominator as 0, that is dx plus dy plus dz is equals to 0. So, which on integration gives x1 plus y, x plus y plus z is equals to c1. Now, another set of multipliers we need to choose, but it is x, y, z. So, each ratio is equal to x dx plus y dy plus dz dz divided by xy minus xz plus yz minus xy plus xz minus yz. So, how to choose the multipliers is very clear. The denominator should become 0. In such a manner, we need to choose the multipliers. So, one set is 1, 1, 1, another set is x, y, z. By choosing so, we get the denominator as 0 and the expression is x dx plus y dy plus z dz is equals to 0, which on integration, what we are getting, that is x square by 2 plus y square by 2 plus z square by 2 is equals to c, or x square plus y square plus z square is equals to 2c2. And then the general solution of the PDE is given by x plus y plus z, that is the previous one. And the now one, x square plus this is y square plus z square is equals to 0. This is the second one. So the complete solution is given by 5 of these two. Hope it's clear.